Good morning, everyone. I've been getting a couple of responses from people looking for clarification on how to graph equations in Mathlab. Now, if you're not familiar with Mathlab, it's essentially Pearson's version of an online homework system. Some things that are similar are things like WebWork or I think Wiley Plus are some other examples, but basically it's an online homework system where you can answer mathematical questions. And one of the questions that seems to be pretty tricky sometimes is how do you actually navigate the interface to graph an equation like y is equal to x squared plus 5. And so that's what we're going to take a look at today. If we look specifically at y is equal to x squared plus 5, you may be able to look at that and already know, well, hey, that's a parabola. So this just comes down to how do we graph a parabola in Mathlab. And we'll get to that too, but let's assume that we got this equation y is equal to x squared plus 5 and we didn't necessarily know exactly what it looked like. How could we start and how could we ultimately solve this problem and then input that answer correctly into the software? And so let's actually bring this back to the whiteboard, and you might want to start by bringing this back to a piece of paper. How can we graph a parabola in Mathlab? Well, we can graph a parabola to begin with, or graph any equation to begin with, by starting from a similar place, and usually a good place to start is with a table. And so what we might do with a table like this is we might decide, let's pick some x values and see if we can find their corresponding y's, so we can come up with a bunch of coordinate pairs, plot those, and then see what that looks like. So for instance, we might say take -3, -2, -1, 0, 1, 2, and 3. Just to get a reasonable sample of some different types of values that will hopefully give us a good picture of the graph. And in this case, these will. And then in our next column, we can look specifically at y is equal to x squared plus 5. And we can take these x values in our first column and plug them into this equation to get a corresponding y. So for instance, we might say -3 squared plus 5, that's going to equal 9 plus 5, or 14. We could keep this going. -2 squared, if we plug in -2 for x, plus 5 is equal to 4 plus 5, or 9. Right, and if we did the same with -1, if we plug in -1, that's going to give us y is equal to 6. If we plug in 0, that's going to give us y is equal to 5, right? And then 6, 9, and 14, and you can check those for yourself to verify that these are correct. But if you plug in 2, for instance, for x, 2 squared plus 5 is going to give you 9 as well. And so what these give us is a set of ordered pairs, a set of xy's. So here, the x value is -3 and the corresponding y is 14. Right here, the x value is -2 and the corresponding y is 9. Right here, -1, 6, 0, 5, 1, 6. We can continue to fill this out the whole way down until we have this big set of ordered pairs that we can then plot on the graph to get a sense of what the picture will look like. And so let's take a look at that next. So if I copy these over, we've got our ordered pairs over here on the left, and we've got an axis here in the center. We might graph this on paper by labeling our axes. So I might label the axes, the x-axis 1, 2, 3 and -1, 2, 3, because those are the values of x that we picked. And then we'll have to choose something appropriate for the y-axis in order to get this to scale pretty well. And so perhaps we go up by 2's, right? And we'll say 2, 4, 6, 8, 10, 12, 14, 16, or something like that. 2, 4, 6, 8, and so on and so forth. And we would take each of these points and plot them along this graph. So for instance, -3, 14 means we go -3 along the x-axis, and then 14, which will be right about here, along the y. -2, 9 means we go -2 along the x-axis, and 9, which should be right about here, along the y. And same thing for the rest, right? -1, 6 is -1 along the x, 6 along the y, 0 along the x, 5 along the y, 1 along the x, 6 along the y, and so on and so forth. And we can plot our graph like this. And now that we start to do this, we can get a little bit better sense of what the picture is going to look like. We can connect these dots, and I'm going to do the best I can with this, even though I don't have the smoothest handwriting, especially on this trackpad. But we'll get something like this, and now is where we can see, oh, hey, that's right. Graphs of x squared give us parabolas. And so now we know that this is going to be a graph of a parabola, and we can take that knowledge into Mathlab with us. Now, there's a couple other features we'll want to look at in particular, or characteristics, maybe a better word there, of this parabola that we can look at, namely this point here, which is known as the vertex. Let me make sure I spell that correctly. Vertex, which is the point 0.05. And then for Mathlab, as long as we know one of these other points, we're going to be able to graph this just fine. So let's go back and see if we can take a look at the actual Mathlab software. And so if we come over here, we can look down at this bottom row of buttons and find a bunch of different variations of things that we can graph with. So for instance, we could graph a circle, we could graph a line, we can graph an absolute value equation, a sideways parabola, or the one that we're going to ultimately use, a vertical parabola, right? Just like the picture we just drew. Now, the way this works is we have to plot 2 points. 2 of these points can determine the shape of our parabola in the Mathlab software. And the first of which is going to be the vertex. So we saw back from our graph just a second ago, if we click back here, right, our vertex is along the y-axis. It's the point 0.05. So coming back to our Mathlab, we will want to go and plot that point 0.05. And that's how we'll start. And then we want to also pick some other point that is on our curve. So we had a whole bunch of points there. For instance, 2,9 was an example, or 1,6 was an example. And as long as we plot one of those other points, then we have our parabola, right? So I can choose to pick 1,6, for example, which was one of our other ordered pairs, or maybe I decide to plot this as 2,9, there we go, and that will also work as well. So as long as I select one of the other ordered pairs that we found and we have the vertex, we should be good to go with plotting a parabola, and we'll see when we check this answer, it comes out good. And so yeah, that's the gist of how you would plot a parabola in Mathlab. I hope you found this helpful. Thank you for the questions. If we do have any more questions, feel free to drop those in the comments below. I'm going to be responding to a lot of these over the next few weeks. So definitely keep those coming. Yeah, again, thank you for your question. I hope you have a great day.